Hi everyone, this is the second part of my video on sine, cosine, and tangent. So we're just going to do a quick recap of what those three things are, and then we're going to use sine, cosine, and tangent to solve for side lengths. So first of all, our quick recap. SOH CAH TOA is your acronym that tells you what your sine, cosine, and tangent stand for. The SO means that the sine of your angle is your opposite side over your hypotenuse. Ka means the cosine of your angle is the adjacent over your hypotenuse. And tangent of theta we get from TOA. OA is opposite over adjacent. So in other words, the O and the H in SO becomes the O and the H in opposite and hypotenuse. The A and the H in Ka become the adjacent and the hypotenuse for cosine, and the O and the A for TOA becomes the opposite and the adjacent for your tangent. Okay, and then in terms of labeling the sides, the hypotenuse, H, you're going to use for your sine and for your cosine, and the hypotenuse is always the diagonal side in the triangle. Always this, sorry, not diagonal. In this case it is. It's the side that's across from your right angle, is what I meant to say, which in this case is the diagonal length. And then the other two are either across from or next to the angle you care about. And of course, there's always two angles in an acute triangle, a 90-degree triangle, sorry. There's two angles aside from the 90 degrees. And so if you care about this angle up here, then the side across from it is the opposite. And if you care about the angle down here, then the side across from it is your opposite. And so which side is your opposite and which side is your adjacent can change depending on which angle you care about. And in the last video, I showed you how to find the angle when you didn't know it using two sides. In this video, I'm going to show you how to find the sides when you know the angle in one of the sides. So let's go through. So given the triangle below, solve for the missing sides. Okay, let's zoom in on this. So we are trying to solve for this n over here. Okay. Now, first we're going to label our hypotenuse. You always want to start by labeling your hypotenuse. No matter if you're solving for an angle or a side, doesn't matter. Your hypotenuse comes first. And that is across from the 90 degrees. Now, you're always going to care about one of your two angles. And if you don't, just pick one and that is the angle you care about. Like we're going to deal with the problem later on today where I say solve for everything essentially. You just need to pick which angle you're going to start with. In this case though, we are given this angle here is 16.1. And so across from 16.1 is the opposite because it is literally on the opposite side of the triangle. And then the last side left then is your adjacent. Now, there are two sides that we care about here. The hypotenuse we have to use because it's the only side length we know. We don't know the O down here, right? O, I don't know what O is. We can't find it either because we don't know N. We don't know this side over here either. So the opposite side then we also are going to use because that's the one we are trying to find. We are needing the opposite side because that's the thing we are solving for is N. So our opposite side is N. Let's color code that orange, I guess. And so if we care about the opposite side and the hypotenuse, is that going to be a sine, a cosine, or a tangent question? And if you pronounce your H's and so, right, you know that SOH is opposite and hypotenuse. So we set it up the exact same way. So for those of you who just watched my last video or were practicing last week, this is very familiar. Sine of your angle, maybe I should write the formula actually. Sine of theta is the opposite over hypotenuse. And so this step, the only thing that changes is what we substitute. We actually know theta in this case is 16.1 degrees. So since theta is 16.1 degrees, we can substitute that in for sine. Sine of 16.1 degrees equals my opposite side, and my opposite side I don't know. It's n. So now I've got a variable for my side because I actually don't know what my opposite side is. So that's my n, and then my hypotenuse was given 12.5 centimeters. I'll leave the centimeters off. We'll just put the units in the last step again. All right, so Now, we're essentially going to use the same skill we've been using all course long, cross multiply and divide, with one extra step is it's not actually a fraction. So by putting it over 1 like this, I've made it a fraction on the left and a fraction on the right so that we can cross multiply and divide in the usual way. Okay, so let's go through and put this on our calculator. So what we're going to do is we are going to do sine of 16.1 close bracket times 12.5 equals 3.46. Okay, let's round that to 1 decimal place. So we'll say n is 3.5 centimeters. And it's always nice to do something called a sanity check. 3.5 centimeters. Does 3.5 centimeters look about right? Yeah, like 16 is a short angle. 3.5 is a lot less than 12. I was expecting something a lot less than 12 because it's such a shallow angle. Okay, cool. So there you go. We've solved for our side n. Let's try another one. And this is essentially going to be the exact same thing. We are solving for the missing sides. Okay. I just realized missing sides. I should read the question. Read my own question. If I'm solving for missing sides, I need to solve for O as well. Okay, so I don't want to use this number that I just found because what if I made a mistake, right? This could maybe be a mistake. Pretty sure it's not. I'm like a math teacher. But it's always best to use the sides that you have, that you're given. And so we're given 12.5 in the question. And so if we're trying to solve for this adjacent side, we're going to want to use the hypotenuse because that was a number that was given in the question itself. So to solve for O, we're going to do CAH, right? C-A-H. Adjacent and hypotenuse are the two sides we care about if we're solving for this O side down here. Okay. So I don't like O as a variable. I just don't like it. It's ugly. It also, O could be confused for opposite. So I'm just going to change that to an X. Okay. So I'm trying to solve for X down here. So CAH is, tells us that we want cosine of our angle, which is still 16.1 degrees, is a fraction. And my adjacent is X and my hypotenuse is 12.5. So let's plug that into our calculator. Cosine of, can't plug it into my calculator yet. Haven't made it a fraction. Now that it's a fraction, I can cross multiply and divide. Okay, so cosine of 16.1 times 12.5 is 12.00. Okay, so X is 12. 12.0, I guess, centimeters. And just a quick sanity check. Does 12.0 make sense? Yeah, like it's really, really wide. It's 16.1 degrees. If it's 16.1 degrees, then it's much, much wider than it is tall. And 12 is less than the hypotenuse, which is good, right? Hypotenuse has to be the longest side. And it's still quite long relative to the diagonal. So I'd like you guys to try this triangle right now. So try to pause, see if you can do this on your own. Okay, you didn't pause, did you? I mean, for real, if you're trying to learn math, you don't learn math by watching. You learn math by doing. So pause this video, find the hypotenuse, label your sides, and then go through figuring out if you need SOH, CAH, or TOA. Okay, so we're back. First thing we're going to do, anytime you're solving anything, you're going to label the hypotenuse. That's always your first step. The hypotenuse is across from the 90 degrees. So that's my hypotenuse. My hypotenuse I know, which is fantastic. We're going to be using that in a sec. But in this case, we're using this angle up here. This angle up here is opposite this side down here, M. And then our last side is our adjacent side. So which one do you want to solve for first? Well, since we did sine first last time, like, you know, let's not be prejudiced against cosine. Let's give cosine a chance. So I'm going to choose to solve for P first because it says to solve for the missing sides. You could have chosen to solve for M, but if you chose to solve for M, you'd need to be doing sine first. Anyway, so CAH tells me that cosine of my angle is my adjacent P over my hypotenuse, which is 18.4 centimeters again. So let's throw this over 1 so that we can cross multiply and divide. So basically the same as last question, cosine 22 times 18.4. And you get 17.1 if you round correctly. You'll notice the 0.06, right? This 0.06 means we're rounding that up to a 1. So P is 17.1 centimeters. Insanity check. Ooh, this 22 degrees, that is way more than 22 degrees the way that this is drawn. The way this should be drawn is like this. So that's a misleading diagram. That's something math teachers that like to do just to throw students off, to make sure that you actually know and understand what's going on. It's a way of checking for confidence, essentially. Yeah, 22 degrees is teeny as a small angle like that. Yes, it makes sense that 17.1 centimeters is nice and long compared to our 18.4 centimeter hypotenuse. Okay, and I'm just going to go through the other side really quickly. You've already done this, so you shouldn't need this. This is basically the exact same as the last question. So sine is the opposite over the hypotenuse. Our opposite is our unknown in this case because we're using these two sides for so. Throw it over 1, cross multiply and divide, and we get sine of 22 times 18.4. 6.9. So M is 6.9 centimeters. Now, I just realized I didn't talk about the backwards calculator while doing this. If you've got a backwards calculator, then you can't actually just do it in one step like I've done here. All that you need to do is you need to do sine of 22. And on a backwards calculator, the way you do sine of 22 would be 22, and then you hit your sine button. Okay, so that's sine of 22. And then you would hit your multiply button, 18.4 equals. Okay, so if you've got like a backwards calculator, do this right now. Make sure you can get 6.89. Okay, cool. Hopefully you're back with me. 6.89 rounds to 6.9 centimeters. Okay, this we did last time. So that's it. That's how you solve for sides. I just wanted to talk about this question right here. Solve. Determine all the missing information in the triangle is what mathematicians mean when they say solving a triangle. Okay, now just a word of caution. When you're solving a triangle, the last angle you can get by subtracting from 180. Now, the problem is if you use this angle up here, then this is your opposite side, right? And if you use this angle down here, 25 degrees, then this is your opposite side. So it's really a bad idea to, well, I shouldn't say it's a bad idea, but often students make mistakes if they label both angles in the triangle, because then which side is the opposite? Which side is the adjacent? Which angle are you using? It's very, very easy to get mixed up. So find the last angle last. And in this case, you can find the last angle just by subtracting from 180 degrees. Because there's 180 degrees in a triangle, your last step in this problem should be 180 degrees minus 90 degrees minus 25 degrees. Okay? And by doing that last, then you aren't going to get confused about which angle you're subbing into your sine, your cosine, your tangent, whatever it is you need to solve this problem. Okay, so I just wanted to give you guys a hint for that one question there. And then the practice is all the other questions I didn't assign last time, which is 2, 3, 4, 5, and 11B. Okay, I wish you success with your practice. Hey, as soon as I stopped recording the last video, I realized I have an example to show you guys what solving means. And it's really important because of the first step that I'm about to do, where your variable ends up being in the denominator. Okay, so don't worry about it. I'll show you what I mean in just a sec. So first of all, solve. Solve means find all the things, all the sides, all the angles, everything. And the way we start, same as always, you label your hypotenuse first, which is the side across from your right angle. So C is our hypotenuse. And then the angle that we have is 18 degrees, which makes this side here our opposite, and then the last side at the bottom then is our adjacent. Now I could find this angle at the top here, but I'm not going to do that right till the end, just because of what I just told you guys. Okay, so I can solve for the adjacent, or I can solve for the hypotenuse. I'm going to choose to do adjacent first, just because we haven't done tangent yet. So let's do our TOA using our O and our A. I know that's a choice because I need to solve for all the things. I could have solved for C here as well. So let's set this up. So TOA, tangent of our angle 18 degrees, is our opposite side, 6.63, divided by our adjacent side, which in this case is labeled B. Now, B being in the denominator, the way some people solve this ends up being a bit of a trickier problem, but if you cross multiply and divide, it ends up being no harder than any other way. Because when we cross multiply and divide, all this means is that tan 18 is in our denominator. So we are going to do 6.63, oops, not v.63, 6.63, and times 1 doesn't matter, so I'll just skip the times 1 and jump right to divide by tangent of 18. And so 6.63 divided by tangent of 18 tells us that B is 20.4. And our units are meters in this case. Okay, so there you go. You cross multiply and divide. You need to divide by your angle if your variable was in the denominator, like in this question. So now let's solve for our hypotenuse. If you really don't like SOH CAH TOA, I suppose you could do Pythagorean theorem at this point. I find SOH CAH TOA really quick, like it's just 2 lines. So I'm going to show you guys how to do this using SO, especially because like that's the unit we're on. So I'm using SO because the opposite we were given, that's the number that I know for sure is right. Even if I made a calculator mistake, I was in radian modes or something like that, I know that that's 6.63. So I want to use that 6.63 to find my h, which means this is going to be a SO question. So sine of my angle, still 18 degrees, is my opposite side. The opposite side was 6.63. So 6.63. And my hypotenuse is labeled as C. So what color did I do that? Oh, I did orange. Okay, so there's my hypotenuse C. So let's throw this over 1, and then we will cross multiply and divide. And again, because C is in the denominator, I'm going to be dividing by sine of 18. 6.63 divide by sine 18, which gives us that C is 21.5 meters. Now, if you've got a backwards calculator for this is actually a little bit confusing because what you need to do on a backwards calculator is you need to do 6.63 divided by, but then the way you do sine of 18 is you actually need to say 18 and then hit the sine button. But you weren't done yet, because if you hit 18 in the sine button, even in the middle, like right here, that actually just shows you the sine of 18. You haven't actually done the division until you end with an equals. So if you've got a backwards calculator, I know it's a little bit confusing, you're going to have to do your 6.63 divided by, and then hit your angle, right, your 18 degrees, and then your sine. So if you've got a backwards calculator, try this right now and make sure that you can get 21.455. Cool. And those of you with this, like a straightforward calculator, you can just plug it in as you want to do it, and it works out. Last step, just find the missing angle. And this is the easiest step, but we do it last, again, because we really don't want to get confused about which angle we're using or which side is our opposite and adjacent. So this is 180 degrees minus the 2 angles we know, which is our 90-degree angle and our 18-degree angle. 180 minus 90 minus 18 is 72 degrees. So there you have it. We have found the missing angle of 72 degrees. We found that B was 20.4 meters, and we found that our hypotenuse was 21.5 meters. And sanity check, yeah, hypotenuse is longer than my B. Okay, good.